So the next heading is synthesis of aromatic aldehydes and aromatic ketones. So in this method of aromatic aldehydes and ketones, we have four different named reactions called as Aldehydes reaction is the first one, side chain chlorination is the second reaction, third one is to get benzaldehyde by using chromic oxide, and the fourth one is a named reaction called as Getterman-Koch reaction. So in this, let us discuss the first one, which is called as Aldehydes reaction. So this Aldehydes reaction is again a named reaction. So in this Aldehydes reaction, the major reactant is toluene. So this toluene is made to react with chromyl chloride, which is given by the formula CrO2Cl2 is the formula for chromyl chloride in the presence of carbon disulfide solution, or you can also use carbon tetrachloride solution, such that it gives rise to an intermediate called as chromium complex. Now a question arises, how to write this chromium complex? So here totally there are three hydrogens. So I will write it as CH, where two hydrogens are left out here, and here chromium is only one, which is an odd number. I'll make it as twice, so that I'll take 2 moles of CrO2Cl2. So this is CH. So two hydrogens are left out. While writing this, I have set it as chromium complex. So to get this chromium complex, it is an addition product. None of the reactants gets eliminated in this. There is no elimination. The entire reactant adds up to give a chromium complex. I will rewrite this as O, chromium, with one more O, along with H, along with Cl2, overall twice. So I think when we rewrite this, you can understand it now. So chromium is twice, Cr2 means it is twice, oxygen is 4 times, 2 times of oxygen into twice, so totally 4 chlorine atoms, Cl2 twice means 4 chlorine atoms. Here 2 hydrogens has been left, I have written it as H2, so that the entire reactants has been balanced. So when this particular chromium complex is subjected to acid hydrolysis, so directly it yields benzaldehyde as the major product. This particular reaction is called as Aldehydes reaction. So after knowing this Aldehydes reaction, the second reaction is called as side chain chlorination reaction of toluene. So let us discuss that. That is called as side chain chlorination. Side chain chlorination reaction of toluene. So side chain chlorination reaction of toluene explains that when particular reactant, that is toluene, is subjected to chlorination in the presence of diffused sunlight, such that here 2 hydrogens gets eliminated, which is replaced by 2 chlorine atoms, such that what is eliminated? 2 times of HCl gets eliminated. So to remove this 2 times of HCl, I need 2 moles of chlorine, so that I can rewrite this particular reaction as CHCl2. So 2 hydrogens has taken away by 2 chlorine atoms, totally 4 chlorine atoms. So 2 hydrogens has been taken away by 2 chlorine atoms, and it is eliminated as 2 times of HCl. Still 2 chlorine atoms are left out, which has been added with this, so that I have written it as C6H5CHCl2. This is called as benzyl chloride, ZAL. This is called as benzyl chloride. When this particular benzyl chloride is made to react with 2 molecules of or 2 moles of NaOH, so this chloro is a very good leaving group. So chloro gets attached with Na to eliminate it as 2 moles of NaCl. This OH replaces the place of Cl, so that I can write it as benzene ring with CHOH twice. So when this particular intermediate is heated at a temperature of 373 Kelvin, So when it is heated to a temperature of 373 Kelvin, water molecule gets eliminated from this, so that I will get the major product as what? Benzaldehyde. So benzaldehyde will be the major product along with the elimination of water molecule. So this particular reaction is called as side chain chlorination of toluene.